in Leicester. Over to you.
Okay, I'll start. We've put these slides online. The link is hidden away at the bottom there if anybody wants to.
We'll put it in the chat in a minute.
Yeah, we'll put it in the chat. We work together. We're both artists and programmers in art and in other fields as well. My background was from fine art. Fania's was from computer science. I went through Loughborough University under Ernest Edmonds when he was running Creativity and Cognition Research Studios. And then we met at the Institute of Creative Technologies in Leicester, where strangely Ernest came back to a couple of years ago. So we've kind of been under that kind of umbrella for a while together. And we started working together a few years ago. The first paper we wrote was a critique of computer creativity evaluation. In other words, a critique of how people evaluate computational creativity. And that was the first work that we did together. That's based on a magic square of 3 with the traditional Chinese colors. And it was a collaboration with another artist that's available online that filters, basically it filters diary entries, people's diary entries, according to how intense the solar wind is at the moment.
Yeah, it uses some of my interests as well, natural language processing and sentiment analysis as well.
Yeah, so we're looking for certain phrases and then we match that to the intensity of the solar weather. That's online. That's from my own obsession with magic squares for years and years and years. That's a hypercard stack, very blurry print. It's all I've got left of it at the moment, but you'll see how it relates in a moment. And that was a work I did with Greg Turner at Loughborough University, which was driven by a heartbeat back in 1999. The heartbeat was the only interface, and that's based on magic cubes, which are magic squares in 3 dimensions. So magic squares, if you didn't already know, matrices, square matrices where the numbers add up the same on the diagonals and the rows and the columns. And that's what we're basing this on. However, we're more interested in the lines that can be drawn if you connect the numbers from 1 through to the whole sequence. The usual way you see this is that version there, the straight lines, but we've started experimenting with different kinds of lines, and you
I think we've lost you, Dave.
Sound has gone for me.
Dave, we've lost your sound. Just a sec. Okay, it looks like Dave and Fania are doing a quick reboot at the moment.
How's that? Can you hear us now?
Yes, we can. Right, I'm glad you're back. Really good. I can be quiet and please continue.
Okay, and you can see the screen okay, can you?
Yes, we can, yeah.
Yeah.
Okay, that's great. So, yeah. So you can see there the amazing sort of contrast between some very symmetrical versions of magic squares and some totally, well, they appear to be random, but they're both from exactly the same set of rules that we explained a minute ago. That was the first work that we did together, exhibited, and it's the first print I think that I've done in many, many years of being an artist. That's an extract from it, and that was shown at Interact in Leicester, which Sean organised. It's a very simple sort of 3-pane triptych of the work we've done so far. And yeah, I think I've more or less said that's one set of rules. Various groups in these, we're interested in what's called the magic line and the interplay between the symmetry and asymmetry, and looking for that sweet balance between order and disorder, or combining the two. And you get that kind of complexity from such simple rules, but those rules sort of escalate, if you like. So when you get to order 5, there are millions of permutations of order 5 magic squares, and order 6, it's kind of through the roof. That's the paper that we've written for the conference. Basically, there's a link there if people want to go directly to that. And the first job that we had, or the first thing that we wanted to do, was to reduce the number of patterns so that we could recognize that some magic square numbers or sequences produced identical patterns, even though the numbers were in different orders. And these transformation diagrams on the right show how the numbers have been swapped from one position to another. So the first job that we did was to reduce the given set of 880 order 4 magic squares down to a much smaller number.
Yeah, because as you can see, that even though the number sequences are different, clearly the numbers are swapped around in different patterns, the magic line is pretty much identical, even though mirrored. So we kind of posit the magic line is trivially similar.
Yeah, so we're arguing for a simplification of the classifications there, which is our contribution to the field, if you like. And on the way to doing this, Fania created this method of tracking the different types, some of which overlap. So we produced this print as a way of sort of showing how the research goes into a lot of detail.
Yeah, so in terms of the code, there's a few things to say. We've written some functional programming algorithms to actually generate these magic squares. There's quite a lot to generate in terms of the lower orders. We have them all. In terms of the larger orders, that's physically basically impossible. We don't have the time in the universe to generate all of these. So we've written some functionality in the web interface to actually collect contributions, to start collecting them in a database. So we have a backend on a server to collect them. We have a sort of JavaScript interface for animating and for displaying them as SVGs, scalable vector graphics, so that you can create these magic lines in a very nice, crisp, really nice, scalable sort of display. And it's a progressive web app. It just means that it's a really nice interface that looks really nice on a mobile as well. And it's all sorts of really nice web development magic going on in there, so it's sort of it's really great. So we're going to demo this now. So
we were working on this right up until this morning.
Yeah, lots of bug fixing going on.
Yeah, we found some bugs 3 or 4 days ago, which yeah. So we've got the order 4s up already, so let's move to that tab.
No, click on it.
Yeah. Okay, should be able to go to that tab now. Okay, this is the kind of starting point. You can see the magic square matrices there. So the thing that might be more familiar to people, and this you might recognize this from Vera Molnar's work and other people that have worked with magic squares. A lot of artists have worked with magic squares, but typically they use the ones that are available in an original publication by Cornelius Agrippa, where Albrecht Dürer got his Melancholia magic square from. But we then started playing with the lines. So the first idea is that we're creating curved lines instead. And then we sort of start to depart from that, and it gets even further away from the originals when we start to experiment with these lines. We've even gone into some colored blocks, for rendering these, and even tetronymos, sort of interlaced chunks according to the colors. The numbers are allocated to certain things. The interface does all sorts of things, but we've got some presets that we're going to show. So let's close that window and start. Yeah. Can we close that window?
Well,
let's come out full screen. Yeah. I think we were trying to be too clever here and make it too smooth. So
stay in the full screen.
Yeah, so you can see there's a lot of variety in these are order 12 magic squares, 12 by 12 grids. We can show them in any of these sort of varieties, and you know, this leads on to what we're going to show in a minute. And the whole interface enables us to adjust, to zoom in on you know, the ones that we might be interested in. I always think that this looks like a bit like a Rennie McIntosh design. But
what you see really nicely there is the different classifications of how they're constructed. So you can see that the order 12, so obviously divisible by 3, by 2, by 4, and you can see very nicely how they're, so an order 12 can be made up of little order 3s.
Yes, like that one.
Yeah.
And it's just a fascinating sort of field where we're looking for commonalities in pattern. I mean, basically we're pattern seekers, and a lot of generative art is about pattern and about rules, and we're creating a generative art generator here. That's the idea. So the next screen was, we've got that. So this is just one example of some of the variations. So the background, we can fill the SVGs in dynamically. You know, we can choose colors that we like. You know, we can change those if we want. And the idea is that we have to curate or select from this to create something that we particularly want to print out properly. So we play with these to get the images that we want, basically. And let's have a look. So the next interesting part is that we're looking at animating these. So this is an example of a running animation that's running out of synchronization. So because all of these have different line lengths, they all begin to phase in and out with each other. And if we
and notably as well, what we've done is we got rid of the space between them. So we've mashed them all together to, you know, to remove the gap, and we're animating the lines so that the line actually draws itself and undraws itself.
Yeah. So we were playing with this kind of idea.
So there's several things going on. It gets quite sort of complex.
Let's have a look at this one. This is the same principle, but with straight lines. Yeah, let's just enlarge those up a bit so that they can see them. So if we blow this up a little bit and then go full screen, you can see the patterns beginning to sort of phase in and out of each other. If that runs for a while, you can see how it's sort of, I mean, we haven't done this yet, but the intention is to project this large in galleries, you know, in a much more sort of strikingly visual color scheme. And we have some ideas of how that would look. So finally, we'll just show this one. So this is another variation on the same theme. People come back to us, people who we've shown these things, say, oh, it looks like a, you know, fill in your own idea here. And we kind of welcome that inventive sort of interpretation. They're not meant to be anything. They're just meant to represent the patterns in various different ways. If that runs for a while, especially if we close the gap down and make them quite small, they will phase in and out with each other and create this kind of interesting, well, we think it's interesting, this interesting sort of series. And because we wanted to work with these animations, but we like them at certain phases, we put in a pause button as well, so that we can turn this on and off. We go, yes, we like it at that point. We'll pause it and print it out at that point. So you get the idea there. Let's show this one.
Yeah, finally, so the other thing we've added in was the ability to take all of these individual magic squares and then overlap them on top of each other. So that now that you have, so this is all the 6 magic squares, and we've taken all of them and overlapped them on top of each other. So, and also obviously what they're doing here is they're also animating them. Just, yeah.
So in this particular one, which we wanted to finish with.
So this is the order 10 magic squares, and they're, and in this particular case, it is in this sort of what we call arc style, and
So it's come a long way from the straight lines of just the magic line. Okay, thanks. I think we'll leave it there. we'll stop this from running, and we'll get back to the conference. I mean, this is quite a technical talk, so, you know, in comparison to a lot of other talks, so we realised that we're kind of, you know.
Well, I think it's much more beautiful than just technical. I think there was we had an evening 2 years ago, a V&A Digital Futures over in Hackney House, and someone had this sort of big screen that really was a computer artwork screen that you might hang in your living room, and some of these latter ones that you've been showing could be very beautiful just to have. They're quite therapeutic because of the symmetry in them that isn't quite symmetry. I think they work on a rather lovely level.
Yeah, exactly. I mean, we sometimes get hypnotized by just experimenting, and we'll stop programming and go, oh, let's just relax and look at that.
Yes, they're very therapeutic. I'm finding them so. You know, I'm getting quite relaxed here just looking at them. I think that's a very interesting side of it. Let's just see if anyone wants to ask you anything in particular.
What is it that makes them magic?
Nothing really. They're called magic squares partly because Cornelius Agrippa, the sort of Renaissance philosopher, took 7 of them, the first 7 of the obvious ones, and allocated them to planets, and people used to use them in magical practice. And before then, they were used in Arabic and Indian and Chinese magical practices as well.
I was going to say, I mean, did Chinese use them for divination as well?
Yeah, they did. They use them for divination and so forth. But we're not doing that. I mean, you can use them for divination if you like, but that's not the goal here.
Well, I think what's delightful, I mean, you know, having read your paper while we were editing it and so on, when you get the animations actually happening, when you get them sort of drawing and disappearing again, you know, with the greatest respect to your paper writing, it doesn't do the visual justice.
Well, we don't have mobile PDFs. Yeah. we need animated PDFs, I think.
Absolutely, but it's fabulous.
Yeah, 3D visualizations, Ian. I mean, absolutely. We don't have enough time in the world.
No. Well, there are a number of people who have presented over the last couple of days where you hope they will come back to EVA 2021 and show us where it's gone next. And I would count yours as one of those that we would hope to see. Whatever happens next, even if you don't know and we don't know right now, then that's all the more fun, isn't it? So
it will evolve.
Absolutely. That's great. Thank you very much indeed. If any